Hi friends, I thought I should do a little video about now it's almost middle of the semester to show you some important aspects. So now every week you need to know I have given you uh, what I would do the course calendar and see what is the due for this week. And then I go here, open the calendar. Okay, my week is okay, this is the week of October 5. So, I have to submit the homework 5 chemical bonding and lab 5 naming. It's a good time now. You need to submit the lab work and everything. So then, so these are the only two assignments we have this week is only these. So chapter 5. And then, in order to find the lecture information, you go to the lecture presentation, and then I have added videos for many chapters, and then chapter 5 you go, okay, and then I'm gonna do a little video about chapter 5. So this is my chapter 5, chemical bonding 1. Chemical bonding is important. You have part 1 and part 2 of it. So why the chemicals bond is important. um, so in we learn about bonding theories, but always Lewis theory is the main theory we are following for the chemical bonding. And then there are three types of bonding: ionic bonding, covalent bonding, metallic bonding. Ionic is always two nonmetals completely electron transfer from a cation to anion. Covalent bonding is two nonmetals sharing, electron sharing between the atoms. Metallic is, if you think about aluminum foil, it's like all metals. So it's important you know about bond polarity. Um, Bond polarity is how electronegative they are when in element when the atoms, all the atoms have different electronegativity in the periodic table. If you look at this periodic table, you see I listed under each atom, okay, there is different electronegativity depending on the electronegativity of the atoms that is bonding, make a bond. They have the we can differentiate the type of bonding. So you see the red color is least, they're not electronegative. But if you think about these, I listed in the purple color, the violet color ones, bromine, chlorine, they are highly electronegative. So in the exam, you can have periodic table just by itself, and also periodic table with electronegativities as well. So how do you know? So the bond can be, there are bonds, polar covalent bond, so the bond types, let me go to the, okay. So these are the bonds. You can classify. So right, still behind covalent bond. What is covalent? Covalent is two nonmetals. If two nonmetals involving in the bonding um, has the electronegativity difference between zero point 0.1 to zero point 0.4, that means like they're like alike atoms. Example, if you think about bonding between two fluorine atoms, the same electronegativity, right? So it's between it's same electronegativity. So if we call it PO covalent, it's the same name as non-polar covalent. And then when you see the electronegativity is zero point 0.5 to 1.9, we call polar covalent. How do you find the electronegativity difference? You go here. Okay, let's look at, okay, HCl. Okay, let me go to the HCl. Mm, what does it? Yeah, so when you go to the HCl, let me write it here. Let's go to this one. Okay, so here in the periodic table, you'll see my why. H, I don't need that. I have HCl. What type of bond is this? I look at my uh, hydrogen electronegativity 2.1, and then I look at my chlorine. My chlorine electronegativity is, this is very small, 3. How do you get the difference? You get the bigger number, 3 minus 2.1 2.1, and then I get electronegativity is 0.9. So then I go see, okay, if it is 0 0.9, which is between 0.5 and 1.9, right? So it's a polar covalent bond. And then you take sodium chloride. See, I know it's a little light. 0.5 to 1.9, it is polar covalent bond. Similarly, the difference is above 2, it is ionic. So this is the simple chart. Small, it's a covalent, like it's Cl, sodium chloride, like that. So then dipole moment is important. Present ionic character. We're gonna do this one. Um, so here I have given you question. Is the bond between each pair of atoms covalent? So what you do, you take strontium and fluorine, find the electronegativity difference. You say, okay, this is depending on the electronegativity difference, you can say it's a polar covalent, pure covalent, or ionic. And then Lewis theory is important. Um, so octet rule. Octet rule is always when atom form bonding, it has 8 electrons. But there are some exceptions. Exceptions means this is it's showing here nonmetals in period 3 and below, they can have more than 8 electrons when they are in the center atom. Example, phosphorus can accommodate more than 8 electrons, but nitrogen cannot because nitrogen is in the period uh, 2. But there are certain other atoms, they don't go to the octet. Example, beryllium chloride, lithium, because they go to their closest noble gas, which is helium. If you think about where the helium in the periodic table, let me see that I have a periodic table readily available. Let's see in a minute. Um, no, it's okay. So in the so think about like let's go to this periodic table. It doesn't have the okay. So it's always think about that if like boron, because they're at the beginning, hydrogen can form without 8 electrons. There are certain the atoms they don't go to 8 electrons. So I will show you how to draw a correct Lewis structure. There are steps you need to follow when you do a correct Lewis structure. Very first rule is when you draw a Lewis structure, first you need to calculate the valence electrons. What are the valence electrons? Valence electrons are electrons in the outermost or highest shell. So when you calculate the electrons in the outermost shell, so the next thing is you calculate valence electrons. Example, I'll take something and show you how to calculate the valence electrons, such as here I have HBr. HBr, how do you calculate valence electrons? So my metal is HBr. I'm asking calculate the valence electrons in HBr. How many valence electrons in hydrogen? Hydrogen is periodic table group 1. So always main group like elements, like not the transition, they have the group number will equal to the number of valence electrons. Hydrogen is in the group 1, valence electrons 1. Can anybody think what is the group for bromine? Bromine is in the group 7. So 7 valence electrons 1 plus 7 valence electrons 8. I'm going to take another one. NO2 minus. Nitrogen is in the group 5. Valence electrons 5. Oxygen is in the group 6. Valence electrons 6 into 2 because you have 2 atoms. Where the negative goes. Negative means you have more electrons, so you add 1. So in its valence electrons, 6 into 2, 12, plus 5, 17. So 18 valence electrons in NO2 minus. So in the writing the Lewis structure, the main thing is calculate the valence electrons. So let's say take the simple Lewis structure, making water. Okay, water. How to throw the Lewis structure? Water. First step, calculate the valence electrons. Valence electrons, hydrogen 1 into 2 plus 6. You have 8 valence electrons. Once you calculate the valence electrons, the next step is identify the center atom. How do you identify the center atom? Always center atom is least electronegative element. Least electronegative element means, uh, so in this one, and there's another thing. Always if you have hydrogen in your compound, it goes to the terminals. Hydrogen will not never be a center atom. So the center atom here is oxygen, hydrogen, hydrogen. And then I need to distribute these 8 valence electrons between these atoms. First, you give the octet to the terminal atom. So 1, 2, 3, 4, you have remaining 4, 8. This is how you draw the Lewis structure. And then I take another compound which is CO2. First, calculate the valence electrons. Carbon 4, oxygen 6 into 2, valence electrons 12 into 16, right? 16 valence electrons. Now, look at the rule. Least electronegative atom, carbon, oxygen, oxygen, and then 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 8, okay? 8 electrons. Always try to give the 8 electrons to the terminal atoms. Okay. And then you have 16 gone. Then you look at the center atom. Is center atom has 8 electrons? No, we need to give the center atom also 8 electrons. For that, what you do? You share these electrons. And then it's going to be C, O, O, double bond. So this is the CO2 structure. That's how you draw a Lewis structure. Okay, so once you know, you can read and understand. Once you draw Lewis structure, I have given you so many examples how to draw Lewis structure. Resonance and the formal charge. Resonance is when you have two or more valid structure for a compound, we call it a resonance. Formal charge is an important one. It's the electron bookkeeping system. There is a formula. Formula is number of valence electrons. So valence charge, the formal charge you can calculate for each and every compound, like each and every atom in a compound. So if I take whiteboard, the formal charge of HF is given. Formal charge equals number of valence electrons minus number of non-bonding half bonding. So HF, I'm asking what is the formal charge for fluorine? So HF is, Lewis structure is like that, 1, 2. Okay, and then what is the valence? So formal charge, you have to calculate each and every atom in the molecule. Valence electrons, 7. Non-bonding, 6, right? You see 6 non-bonding because these are bond 1, 2, 3, 4, 5, 6 non-bonding, half bonding, half bonding 2, 2, 2, 2, 1. It is, what is the valence? Like 7 minus 7, right? So the formal charge is 0 for the uh, HF fluorine. And then you go to the, similarly they found the formal charge for SO2. Always when the molecules, they try to minimize the formal charge. Can try that way, finding the formal charge. And then I'm talking about odd electron species like nitrous oxide. would be the odd electron species. You can look at that. And then bond energy is also important. Like always think about that triple bond has the strongest bond energy and shortest distance than single bond. And then bond strength we do, and then I'm going to show you something here. Molecular geometry, very important concept. Okay, Vesper theory. Vesper theory is very important. We talk about molecular geometry and electron geometry. So these are the main geometries we are talking. So we have linear geometry. If you have two electron groups around the center atom, it's going to be linear. And then three electron groups, it's going to be trigonal planar. Four electron groups, it's going to be tetrahedral. Five electron groups, it's going to be trigonal bipyramidal or electron geometries. And then six electron groups, octahedral. But when you make these geometries, um, these only you consider electron domains around the central atom when we give the electron geometry. But molecular geometry, you identify them as, okay, how many bonding atoms, how many non-bonding atoms. Like that, they're always for a certain, if you don't have lone pairs, molecular geometry, electron geometry is same. But whenever you have the lone pairs, then it's going to be different. Let me take, so this chart will be very important, but let me take one or two examples and explain this, because you can always read the PowerPoint. Let me take water. Okay, so water, we already did the Lewis structure, HOH. Okay, so now I'm asking what is the electron geometry for water? Electron geometry for water is how many electron domains around the central atom? I can see 1, 2, 3, 4. 4 electron domains around the center atom. Electron geometry is tetrahedral. But molecular geometry is not. Molecular geometry is, you look at how many electron groups, 2 bonding, um, 4 non-bond, sorry, 2, these 2 are bonding. And similarly, let me take another nice color for you. Okay, let's use this one. Okay, okay. And then these are non-bonding. Okay, non-bonding, or else lone pairs. So then we call, okay, molecular geometry is bent. So that is how you find, okay, that is electron geometry, this is molecular geometry. Let me take another one. NH3. You find the valence electrons, you find the um, center atom, N, H, H, H. Okay. So I'm asking electron geometry. Electron geometry is how many bonding domains, 1, 2, 3, 4, 4 domains. Electron geometry is tetrahedral. Molecular geometry, 4 electron groups around the center atom, 1 lone pair. It's going to be trigonal pyramidal. Okay, so like that, always molecular geometry and electron geometry is different. So in chapter 5, it's important we learn about bonding. We did bonding, like how do you look at electronegativity. We learn electronegativity. Each and every atom in the periodic table, they have own electronegativity. And then we look at the electronegativity difference. So by looking at the electronegativity difference, you can predict, okay, it is the um, pure covalent, polar covalent, or ionic. And then we talk about what else? bond, the bond, how strong is the bond, and then formal charges, resonance, and then we came to the Lewis theory. Lewis theory is important aspect as well. So I hope this video helped you to understand a little